Good morning, student. In the previous classes, we have seen the chapter relation and function, and we are solving questions of miscellaneous. Okay. Now, students, we have solved some questions. Now, today we will see some other questions of relation and function. Okay. So let's see. Our first question is: give a non-negative set X. Let star from P of X cross P of X tends to Px. Star from P of X cross P of X tends to P of X. Be defined as A star B is equal to A minus B, B union A minus B dash. So the A minus B minus B minus A. For R, AB belongs to Px. Then so that phi is the identity element for the operation star. Okay, and all the element of Px are invertible with A inverse is equal to A. So we have to show that this phi is identity element. Okay, students, we have to show that this phi is identity element. So, students, for any A belongs to Px, we write A star phi is equal to A minus phi minus A. We have taken at the place of B is phi. Okay, students. Now this we can write A intersection phi dash union phi intersection A dash. Okay, students, and you know this A intersection phi dash can be written as U, because U minus phi we will write, so we get U. Now union here U minus A, which is phi intersection A dash. So this will be equal to, student, phi. We are taking common between phi and A dash. Okay. So it will be what? Phi. Now, students, we write. Now here we are saying that this is A intersection U. So this is equal to, A, student, and union phi. So this is equal to A. Okay. Now, student, we write, if we are taking this is A star phi. Now we are taking phi star A. Okay. Now we are taking phi star A. So we write, student, phi minus A union A minus phi. So this we write phi minus A is phi intersection A dash union A intersection phi dash, and students, phi intersection A dash is phi, because phi intersection A dash is phi, and union this we can write, student, A intersection phi dash. A intersection phi dash is equal to A, and this is equal to again A, phi union A. Okay, students, so we are seeing that our A star phi is equal to phi star A is equal to A. We are seeing that this A star phi is equal to phi star A is equal to A. It means that this phi is identity element. Okay students, because we know that if A star E is equal to E star A, then our E is identity element. So we are seeing from here our phi is A and this is A star E is equal to A, so our phi is E, that is our phi is identity element. Okay students, and for all A belongs to P of X. Okay. Okay students, now student we have to find inverse. So for this student, what we will do, we take for any A belongs to Px. Okay, you know we write A star A is equal to A minus A union A minus A, and this is phi union phi, this is phi. Okay, and this is equal to A star A, and this we write student A is equal to A inverse. This implies A is equal to A inverse. This proves that. Okay students, so students, in this question says that given non-empty set X, let this star from this tends to this defined by A star B is equal to A minus B union B minus A, then for any A belongs to Px, we are getting any A of this. So A, for any A belongs to P of X, our A star phi will be, we have changed this with phi. So phi, and you know, we know that the property that A minus B is equal to A intersection B dash. By the property of set, we can write this in the form. So this we can write this and this we can write this. So intersection U and union, this will be again, and this phi intersection A dash will be equal to phi, and this is A U intersection U is A, and this will be union of this is A. Okay, again phi star A students we are taking, we write the definition, from the definition phi minus A minus phi, we again expand this, and this we write phi, and this is A, so this is equal to our A. Now we are saying this A star phi is equal to phi star A is equal to A, so this phi is act as a identity element in that set. Okay, students, so phi is an identity element for all A belongs to Px. Okay, now students, for all A belongs to X, now for any A belongs to Px, we write A star A is equal to A minus A union A minus A, so we get phi, and A star A is equal to phi. It means that students we write our A inverse is equal to A. Okay, I hope you understand students. Now we move to next question. Okay students, now next question is student, set A is equal to, let A is equal to n union 0 cross n union 0, and star be a binary operation on A, star be a binary operation on A, Then find its identity element. Okay students, so we have to find its identity element. Our question is, our set A is equal to n union 0 cross n union 0. Then star be a binary operation on A, then find its identity element. Okay students, so we have to find a binary operation, and it is defined by AB star CD is equal to A plus C and B plus D for all ABCD belongs to A. Okay students, it is this set and star be a binary operation on a set A and defined by this. So students, we have to find its identity. So students, this is given in the form of order pair, so we let the identity element is x, y of A. Okay. Our identity element in A is x, y. Okay students, and you know that AB star xy is equal to AB for all AB belongs to A. Okay students, because students, if our identity element is E, then A star E is equal to A, we write. Okay, here our identity element is xy because the set is given in order pair, Cartesian product. Okay, so we are taking in order pair. So A star E is equal to A. Okay students, now we apply this. It is defined by AB star CD is A plus C, first and third. So we write A plus X and B plus Y. This is equal to A, B. Now comparing both sides, student, we write our A plus X is equal to A, B plus Y is equal to B, and from here X is 0 and Y is 0. So students, clearly 0, 0 belong to the set A. Okay, clearly 0, 0 belong to the set A. So we write zero zero star AB is equal to AB for all AB belongs to A. So this 0, 0 is identity in A. Okay students, I hope you understand. Because our set is given in the form of order pair, that's why we have taken our identity element A cross. Identity element is xy, which is belong in A. Okay, now we know A star E is equal to A. So students, A plus X, B plus Y, this is equal to AB. So A plus X is equal to A, B plus Y is equal to B, and this is 0, this is 0. So 0 belong to A. 0, 0 star AB is equal to AB star for all AB belongs to A. So 0, 0 is identity in A. Okay students, so I hope you understand this question. Now we take another. Next question, student. Consider a binary operation star from R cross R tends to R and defined as A star B. A star B is equal to mod A minus B, and A operation B is equal to A. It is defined by this and this A. Then so that star is commutative but not associative, and operation O is associative. This is commutative but not associative, and this is associative but not commutative. Okay, student, this is we have to show that. So students, first we are taking the operation A star B is equal to A minus B, and we are checking first for commutative. Okay. Now students, taking for any two element of R. Okay. So it is defined that A star B is equal to A minus B. So student, A minus B is positive. If we write B minus A, this is also positive. So this we write, this is equal to B star A. So A star B is equal to B star A. So star is commutative on R. Okay, students, because both are same, now we check for associative. So students, we are taking A star B star C. We are taking any, like A, B, C belong to R. Okay. So we write A star and this is B minus C. Because B star C is defined by A minus B, A star B is defined by A minus B, so we write B minus C. Now this we write again A minus C. Okay, students, A minus B minus C. Now we check A star B star C. This is, so we write A minus B star C. Okay, now this we write A minus B minus C, because this is, okay students, this A star B minus C. So we are clearly seeing that A star B star C is not equal to A star B star C. So star is not associative. Star is not associative. Okay, students. So first part is clear. In first part we have to prove that it is this star is commutative but not associative. So we have proved that the star is commutative but here not associative. Now we check its second part. In second part we have to prove that it is not associative but not commutative. So let's check. Second part is A operation B. This is equal to A. Okay students. So for commutative we take again for A, B belong to R. Our A operation B is equal to A. Okay. And if we are taking B operation A, this is equal to B. So A operation B is not equal to B operation A. So operation A is not commutative binary operation. Okay students. Now we take three elements A, B, C belong to this R and we check A operation, B operation, C. So this is A operation and B operation C is equal to B and this is equal to A. And A operation, B operation, C, this is equal to A operation C and this is equal to A. So from here we are seeing that this is associative. So operation O is associative binary operation on R. Okay students, I hope you understand both part clearly. So in this way we can find either we can prove commutative and associative. Our next question is student. Our next question is student. A binary operation star on a set 1, 2, 3, 4, 5 including 0. Our A star B is defined that A plus B if A plus B less than 6, A plus B minus 6 if A plus B greater than equal to 6. Okay, and then we have to show that this 0 is identity element, identity for this operation. So students, let A be an arbitrary element of the set A. And students, if 0 is identity, so we write A star 0 is equal to, we get A plus 0 because 0 is less than this. So this we get A. And 0 star A is 0 plus A, this is also equal to A. So we say that A star 0 is 0 star A is equal to A. So this 0 is identity element of A. Okay students, so this proves that 0 is identity element for this set, and this is for all A belong to A. Okay, so this proves that 0 is identity element of this. And now we have to find for each A of the set is invertible with 6 minus A. Okay students, now for inverse, this is for identity. For inverse, let A be an arbitrary element of A again. Okay students, and we take A star 6 minus A. This is equal to, we write A plus B minus 6, that is A plus 6 minus A minus 6. So this is equal to 0 student, and this is equal to 0. Okay, and this is identity. Now we take 6 minus A star A, which is 6 minus A plus A minus 6. Again we are saying this is 0. So student, we are getting from here what we are getting, that this and this A star 6 minus A is equal to 6 minus A star A. This is equal to 0 for all A belongs to set A. Okay students, for all A belongs to the set. So we say that each element of is invertible with 6 minus A. Okay, so let's see once again students. And this question, this is a set and defined by this, and question says that what is its identity and what is its inverse. Okay, so no, sorry, we have to prove that 0 is the identity element of this and 6 minus A is the inverse of this element, any element of this set. Okay, so for identity element we have taken any arbitrary element of this set students, and you know, if we are applying with the identity element, it gives us that element. So we write A star 0 is A plus 0, which is A, because this is less than 0, so this function will be considered. So 0 star A is 0 plus A, which is A. So both in case we are getting A star 0, 0 star A is A. It means that this 0 is our identity element of A. Okay, now for inverse, we again take an element A, and now you know, for inverse A star B is equal to identity is equal to B star A. So our inverse is this B, and this B is 6 minus A. So here A star B is equal to, we are getting A star B. So this is greater than, okay, so we write, because this is greater than this, A plus B minus 6 is greater than equal to 0. So this we write A plus B minus 6, so we write 0, and again we are taking 6 minus A star A. Okay, then we are getting again 0, so our A plus B is equal to B star A, which is gives us our identity. Our A star B is equal to B star A gives our identity. So this means that this is our inverse. This proves that this is inverse of any element of that set. Okay students, so I hope you understand. Now we see some other question in the next class. Thank you so much for today.